Hello my students in grade 6, this is Miss Mary and this is the second video in the fourth quarter. In this video we will complete our lesson 1 about pure substances and mixture. In the previous video we spoke about the pure substances. Today we will speak about mixtures. Before we start, I want you to open for me page 55 in the book and let's start. Do you remember in the previous video we said when we freeze water, the water will not change. The water molecules will stay the same. They are all still made of 2 hydrogen and 1 oxygen, like here in the picture here. And the physical change cannot break down the bonds here. To break the bonds we need chemical change. So the question 11 in page 55. In this question is asking, identify what happens when a pure substance undergo a chemical change. If you remember, what will happen after chemical change? What will happen? Yes, the chemical bonds that hold the atoms together are broken. A new substance is formed, like here. By chemical change, the chemical change will break down the bonds between the atoms. We said that between atoms we have connection here called chemical bond. By chemical change, the bond here break down and the two atoms will separate or move away from each other. In page 56, identify, as you read, underline the ways in which elements are organized on the periodic table. If you remember also in the previous video we said that we have over 100 elements and each element has a place in the arrangement in the periodic table. We classify elements, or we group elements into 3 main groups: metals, non-metals and metalloids. So please highlight with me. As I read, you will highlight in your book. Metals, non-metals and metalloids. We have 3 groups of elements. They have different regions or different places in the periodic table, and we will see this in the next slide. Metals start at the left and make up most of the elements in the periodic table. Non-metals at the right, and they have different color from the metals. And metalloids between them, between metals and the non-metals. So please highlight till here. Okay, so we will start from where the metals until here non-metals, and let's see in the periodic table where they are. Here the 3 groups. Metals, we said metals are good conductors, shiny, malleable. Non-metals, not shiny and dull, they don't conduct electricity or heat, they are brittle or easily break down. Metalloids between them, they have some properties of metals and some properties of non-metals. They are somehow conductors for electricity but not good as metals, and also not bad like non-metals, and we call them semiconductors or medium conductors. Some of them are shiny. Metalloids are somewhat malleable, they also a little bit malleable and ductile, they can be drawn into wires, and they are conductors for heat and electric current, but as we said, not good as the metals. Here the periodic table, and we will see where every kind of elements found. In this part, the big part of the periodic table on the left, so the left side from the periodic table, they all are metals. Yes, all the blue color, all these elements like gold, like silver, like aluminum, like zinc, like copper, iron, all of them, they are metals. And then on the right part, the yellow part in the periodic table, this is for non-metals. And the metalloids are these 6 elements. Let's count them. 1, 2, 3, 4, 5, 6. All the green part, they are metalloids. So when I ask you, where are metals in the periodic table? You will tell me where. Yes, on the left side. Where are non-metals in the periodic table? You will tell me, yes, on the right side. So metals on the left, non-metals on the right. Where are metalloids? In the middle between metals and non-metals. Okay, so another question. When I ask you, most of elements in the periodic table are metals or metalloids or non-metals? Most of elements They are, yes, they are metals. Look here, how much elements are metals. They are more than the metalloids and non-metals. Okay. Okay, so let's move to the next slide, and now we will speak about the mixtures. Mixture is a combination of two or more substances. When you mix things together and they combine physically, they just found together, but they don't have any chemical bonds between them, and we will explain this. Mixtures are not pure substances because they have more than one substance together. If you remember, we said that pure substances like elements because they have only one kind of atoms, and compounds because they have only one kind of molecules. But in the mixture, we can't say that mixture is a pure substance because it has many substances together. Like pizza. Pizza is an example of a mixture because it has here, as we see in the picture, olives, tomato sauce, and mushrooms. Many things mixed together have definite properties and mixtures and compounds. Because maybe some of you will get confused how compound is a pure substance and it has two types of atoms. But here the two types of atoms, they join together to become one thing here. Okay, they become one thing. They have chemical bond here. So when they have chemical bonds, they consider as one molecule. So the compound has one kind of molecules. Okay, but in the picture, in the mixture here, we have two types of elements together, two types of atoms, and they don't have here chemical bond. They are just mixed together, like the oxygen and the hydrogen molecules together. Okay, this is a molecule for hydrogen, and this is molecule for oxygen. Here two atoms together, they form a molecule. Okay, so this molecule for oxygen and this molecule for hydrogen, and look here, they don't have any chemical bond between them. Okay, so in this case we call it mixture, but when they have bond between them we call it compound. Okay, so mixture, let's start solving this question. Mixture, and this you will find this in page 58. So open with me page 58. Here the girl here, she's trying to mix the salt and the sand together inside this beaker. So the question is, sand and salt are poured into a single beaker. The result is a mixture. Because why this we consider it as a mixture? What do you think? Because sand and the salt are not chemically combined. There is no chemical bond between, just mix it together, and they don't have chemical bond between them. Mixture can be separated. This is the first property of mixture, that you can separate mixture. You can choose them by picking by hands, like here. You can make them groups, or you know, the first way to separate mixture by hands. Also, mixture can be separated by boiling. If we have salt water here, by boiling the salt water, the water evaporates as we see here, and leaving what down? The salt. So in this way we separated the salt from the water by boiling. Okay, another way also to separate mixture by using a magnet. If we want to separate nails from non-magnetic substance like sand, like papers, like glass, you can separate iron using the magnet. So this is another way to separate mixtures. And also we have a machine called centrifuge. This centrifuge is a machine that spins very fast. If you look here, they put inside here the tubes or the things, the liquids that you want to separate, and it spins very fast. And they use actually this centrifuge to separate the blood components or the ingredients of the blood. They put the blood inside here, and it spins very fast, as I said, and then it separates the plasma from the cells down, the red blood cells and the white blood cells, and the plasma, which is the liquid part, which is made of water and the blood, it gets separated from the cells. So centrifuge also is a method or a way to separate mixtures. Okay, so till now we said we can separate mixture by hands, we can separate them by boiling, we can separate by magnet, we can separate by centrifuge. So the question here, let's solve in page 59. In this question, how could you separate mixture of rocks and sand? If you have a mixture of sand and rocks, large rocks, how can you separate them? Which way from the ways I said you can use to separate rocks out of sand? Yes, we can separate them by hands. I could pick out the rocks using your hands. Very simple. You can notice the rocks because they have a larger size and you can pick them easily. Okay. So in this question, we have also mixture that made of sand, salt, and water. Okay. First, let us see a video and then we solve this question together. So let's see in this experiment how we can separate salt, sand, and water. Things that we need for this experiment: we need salt, we need sand mixture, water, filter paper, and 2 beakers, kettle, and a metal plate, and some ice. Okay, and burner or heater. First we will put the salt and sand. Here we mixed the salt and sand together and then we put them inside here and we mix them completely, so the salt will dissolve but the sand will not dissolve, will stay down, will settle out. Do you see here the sand? So the salt dissolved and the sand stayed or settled to the bottom. Okay, after this we will bring the filter paper, we will put it on the beaker and then we will filter the mixture. The sand will stay on the top and the salty water will go down. Okay, because sand particles are very large, so they stuck on the filter paper and only the salt water will go down. After this we will take our salty water and put it inside the kettle and we will boil the water inside by using the flame or heater, and we will make boiling. Look here what comes out, the water vapor. The water vapor goes out and cold surface. The water vapor condenses and change back to water liquid. So we will bring this beaker to collect the water drops. What will stay inside? The salt will stay here and the water in the cup. And if you remember, the salt, the sand was taken by the the filter paper. Okay, so let's now solve the question here. In this part, when water is added to the sand salt mixture, what will happen when we add water to the salt and sand together? What will dissolve? Here we answered this question. What will happen? The salt dissolves in the water but sand doesn't, like what we saw in the video, that the salt dissolved but the sand settled out in the mixture. In the next question, when the liquid is poured through a filter, when we put the liquid inside filter, what happened? Yeah, the salt water passes through the filter and what's the sand is stuck inside here, but the salty water passed through the filter paper. Then the remaining salt water in heating, after heating, what will happen? The water salt boiled off, leaving salt behind. The water evaporates and leaving what inside? The salt. So this is the steps how to separate a mixture made from salt, sand, and water. Okay, so this was everything and see you in another video. Bye bye.